we need to go from factored form to standard form. So when we are going from factored form to standard form, we need to go in the form, we need it in the form y is equal to ax squared plus bx plus c. So right now it is not. So what we should do is we should expand it, aka FOIL it out, aka use the distribution property. And there are several ways of doing it. It depends on how you group the pairs. Because multiplication is a binary operation, you're doing two at a time. So we can group it. I personally like to group it like this. I like to FOIL out the two binomials. So foiling means just first, outer, inner, last. We need to do x times x. That's the first two terms. We need to do x times x. X times x is x squared. The outer two terms, which is x and 2. So x times 2 is 2x. We need to do the inner terms, which is negative 7 and x, which is negative 7x. Then negative 7 times 2 will give us negative 14. And the reason why we're using the a square bracket instead of parentheses is just to help us distinguish between the parentheses and the pairs. Right? You could definitely use the parentheses if you prefer. Now we can combine like terms. We have 6, and we can always switch it back to parentheses if you prefer. So we can convert that back to parentheses. X squared. So 2x minus 7x is minus 5x, and a minus 14. We need to distribute the 6 to each term now. So y is going to be 6x squared minus 30x, and then minus 84. So this is our answer. We need to type 6x squared minus 30x minus 84. Right. And the way that delta map does it is a very common way of doing it. You want to expand out the quadratic without the coefficient first and then distribute the coefficient. But it's really depending on you. You could also could have paired up the 6 and the x minus 7. But I believe this is the more efficient way of doing it to save the coefficient for last. It helps a little bit with the multiplication. So the next type of form that we need to go is from vertex form to standard form. And to go from vertex form to standard form, it's very similar to go from factored form to standard form, except there's a bit more work. We have y is equal to 6 times x minus 4 squared minus 6. So I highly recommend that you rewrite the quadratic as y is equal to 6. Since we're doing x minus 4 squared, rewrite it out twice so we don't mess up when we FOIL. So there we have it. So as you can see, it's kind of similar to going from factored form back to standard form, right? But there's this pesky little minus 6, so don't forget that. Let's group them. So let's group these two, and we're going to FOIL. So we do x times x, which is x squared, x times negative 4, which is negative 4x, Negative 4 times x is the same thing, negative 4x. And then don't forget that negative times a negative is a positive, so it's a positive 16. You close the bracket, and there's this minus 6 towards the end. So let's not forget that. And then we distribute the 6 to each and every single term now. Or what we could do is we could combine like terms. So it's just a matter of preference. And I want to switch the square bracket down to a parentheses. So we have 6 parentheses x squared minus 8x plus 16, close parentheses, minus 6. Once we're done, we distribute the 6 to each and every single term. So y is equal to 6x squared, then minus 48x, and 6 times 16, that will give us, what, 96, minus 6. Then we just combine like terms. We have these two coefficients. Sorry, not coefficient, constants. So we have 6x squared minus 48x. And then 96 minus 6 is a 90. So 6x squared minus 48x plus a 90. And there we have it. So in this example, y is equal to x squared plus bx plus c. Our equation is x squared plus 4x plus 6. So we need to identify first what b is. B is equal to 4. Figure out what b over 2. We gotta figure out what b over 2 was first, but that's fine. B over 2 is 4 over 2, which is 2. And then figure out what b over 2 squared is. B over 2 squared is just 2 squared, which is 4. So, great. To complete the square when a is 1, it's always going to be y is equal to x plus b over 2 squared, because that creates a perfect square binomial, plus c minus b over 2 quantity squared. So we know what each individual stuff are. So b over 2 is just 2. So it would be x plus 2 squared plus c was 6 minus b over 2 squared, which was 4. So that's it. We need to clean this up. 6 minus 4 is 2. And we are finished. So let's type it in. X plus 2 quantity squared plus 2. We spent a lot of time doing that. So now let's rewrite the quadratic function in vertex form, given it in standard form. And for type 1 is when the coefficient is 1. The leading coefficient a is 1. So when you have some of this format, x squared plus bx plus c, what we do is we complete the square. So in case you forgot how to complete the square, this is how we do it. First, the first step is to take b, right? We divide it by 2. This comes in handy later on. We will see this a lot. You see this in the quadratic formula a lot. So we take b, we divide it by 2. So when we do that, right, so we have x plus b over 2, then we square it. So when we do this, this is a perfect square. However, it gives us like an excess, because when we FOIL this out, we have x plus b over 2 times x plus b over 2. When we FOIL this out, this becomes x squared plus b over 2x plus b over 2x plus b squared over 4, right? AKA, this is sometimes written as b over 2 squared. So the issue is that we have a plus c here. So to compensate, what we have to do is we can't just create matter, we have to balance it out, as all things should be. So we need to also subtract b over 2 squared, right? So initially we have the plus c, so we account for it, but this b over 2, we need to make it a perfect square, so we have this b over 2 squared, but that's not the actual problem, right? We need to balance it out by subtracting b over 2 squared. So let's see that in action. So for example, if we have y is equal to x squared plus bx plus c, and we have y is equal to x squared plus x minus 8. First step, figure out what b over 2 is. B is 1, so b over 2 is 1 over 2. Second step, figure out what b over 2 squared is. B over 2 squared is equivalent to 1/2 squared, which is 1/4. So when you complete the square, this will become y is equal to, it's always x plus b over 2 squared, so it's going to be x plus 1/2 squared minus the 8, but we need to balance it by subtracting b over 2 squared, which we knew was 1/4. So it would be x plus 1 over 2 squared minus 8 minus 1/4. So we need to do a little bit of math here, and we need to figure out what minus 8 minus 1/4 is. So the previous equation was y is equal to x plus 1/2 squared minus 8 minus 1/4. Okay, so we need to find a common denominator. So this common denominator should be 4, because this is a 1. So we need to work this out. So we have x plus 1 over 2 squared minus 8 times 4 is 32. So we have that. And because they have a common denominator, we can just combine the numerators. So y is equivalent to x plus 1 over 2 squared minus 33 over 4. So I believe on delta math, you can write it as a decimal, so you technically could write it as 0.5, but let's keep it as a fraction. Squared minus 33 over 4. Right? And the way that delta math does it, it works the same way. You need to find b, determine what b is, take a half of b, and b over 2 squared, figure out what that is. So you always need to add and subtract, because it's kind of like creating and destroying matter. You need to balance it out.